In this video, we will discuss shock waves. Shock waves is a strong pressure wave in an elastic medium such as air, water, or solid substance produced by supersonic aircraft. It is a phenomenon that creates violent sound. Any fluid that propagates at supersonic speed gives rise to shock waves. Shock waves are produced in nature during earthquakes and lightnings and detonation. See, this shock wave is a thin transitive area propagating with supersonic speed in which there is a sharp increase in density, pressure, and temperature. So, examples for the shock waves are exit flow from rocket engine and balloon bursting. Shock waves cannot be heard, but we can hear booming sound. The booming sound is called as sonic boom. Then we'll discuss what are the types of shock waves. See, there are many two types of shock waves: normal shock waves and oblique shock waves. See, we'll see what is a normal shock wave. See, if the shock wave is perpendicular, to the flow direction, then this type of the waves are called as normal shock waves, and the normal shock waves are easy to analyze. See, you see the figure. The figure shows NSW means normal shock waves, OSW means oblique shock waves. See, the oblique shock wave is a shock wave that is inclined with respect to the upstream direction. See, we can observe that with the help of diagram, that is OSW. There is a, for example, if it is an object or any projector, any aircraft is moving, it makes a certain angle, that is called as oblique. That is called as waves are produced during that condition is called as oblique shock waves. So we will discuss what are the difference between normal shock waves and oblique shock waves. See, this normal shock waves always occurs when the Mach number is greater than 1. The same condition in case of shock waves also. See, and then come to the normal shock waves. Normal shock waves flows the direction normal. Then in case of oblique shock waves, that is inclined, object is inclined to the flow direction. Then flow direction in the normal shock waves doesn't change. In case of oblique shock waves, definitely there is a flow direction change. Then the downstream, in case of normal shock wave, the downstream of shock wave flow is always subsonic. That can be observed with the help of the again diagram, that is M2, that is less than 1. Then in case of oblique shock wave, the downward shock waves may be subsonic or supersonic. It may be less than 1 or greater than 1. Then come to the strength. The strength of this normal shock wave is high. Then come to the oblique shock waves, the strength is less. Then come to the next concept, that is the application. Application of the shock waves are, normally the shock waves have the application outside the aviations also. Then this can be used for a medical field for the treatment or breaking up the kidney stones and gallbladder stones with the help of this shock waves technique without any surgery. Then the cell information. By passing the shock waves of suitable strength, DNA can be pushed inside the cells without any affecting the present or functionality of the DNA. See, this is a very important in a medical field. Then wood preservation. In order to avoid the microbial attacks on the wood, with the help of the shock waves, some chemicals can be injected into that wood. Then the shock waves also used to study the gas dynamics. Then for the treatment of dry borewells, see, in case of the borewells, there is a problem with the dry borewells is the accumulation of sand particles. With the help of this shock waves, we can easily convert that dry borewell into water source. Then come to the very major application, that is shock waves can be used to assist in needleless drug delivery. See, with the help of these shock waves, The drugs can be injected to the body without using a needle. See, that is, the drug is filled in a cartridge and which is kept passed on the skin, and shock waves is sent to the body with a high pressure. See, in this way we can assist the needleless drug delivery without any pain to the patient.